So tuples are kind of like list, but with the different feature that these are immutable data structures. So that means you won't be able to edit the contents or elements which are already in a tuple. So basically they are read-only elements. So usually they are kind of like the returns from any of the methods that we will be able to only read, and we won't be necessary to edit it. So kind of like we already mentioned, string is a immutable data structure, and tuples I kind of like string but with the features of list. So take an example, div mod is a function which would return, so when you do a 10 by 3 it would return its quotient along with the remainder. So here the quotient would be 3 and the remainder would be 1. So it would return a tuple, type tuple with 3 comma 1. So let's see how to define a tuple. Defining a tuple is pretty simple. So you just instead of just like we used to define a list with the square bracket, we define it with the parentheses. That becomes a type of tuple. So let's also you can just check it out. So let's print this. Yeah, so we'd get the type as tuple. And so every time you specify with the comma operator the type automatically it converts it into a tuple with the parenthesis. So as we have already seen in some of the places, just like now string operator, when you multiply it with any of the constant with using a multiplication operator, you would get a multiple of that tuple value. So 27 comma 27 get, so it basically multiply that elements inside the tuple. And so you can using the tuple method, tuple function, you can basically convert strings, lists into a tuple if it's possible. So a list could be converted into a tuple, just like here, as you can see here, it's a tuple. And similarly, if you want to convert string into a tuple, you just specify tuple we call this tuple function. It would convert it into a tuple with each character becoming as an element of the tuple. And so similarly you can perform indexing just like a list, and you can do a slice operation just like list, but the only thing is you won't be able to assign anything to a replace any value or assign anything in that particular pointer of the tuple, object of the tuple. So other things are, so you can do the mapping of tuple. So basically when you return a value from tuple, you can directly assign it to a variable with comma operator. So there are different types, any way you can do. So you can basically assign a tuple to a tuple with these three variables. So what this will do is, so it's basically going to assign a, b, c, alpha, beta and gamma to a, b, c respectively, and this does the same thing without parentheses, but it assigns it to a, b, a comma b comma c. And also you can just define something like this. This would also give the same answer. Whenever you apply a comma operator, it just becomes a tuple. And you can assign a list to this ABC, and you can assign a tuple to a list. So these are the mapping you can do from list to tuple, string to tuple, tuple to tuple. And these are some complex unpacking or complex assignments. So if you assign this particular tuple while having an inner tuple, so this would basically, 1 would assign to w, 2 comma 3 would be assigned to xy, and 4 would be assigned. So Python is intelligent enough to sequentially assign these to each other. So or else what you can do is just check it out by just giving x, and you can print out the x here. So now 2 comma 3 would be assigned to x. So as you can see here, we printed out x, that's 2 comma 3. So x is a new tuple, or you can just specify it like this. So in this case what happens is z would not be having any other value. So z, so this would basically give an error, because while unpacking it needs more than 3. We have only 3 elements, but this is requiring. So if you pass a fifth element, that would get assigned to the fifth x y z. Z would be having a value. Yeah. Okay. And going forward, so there are a lot of built-in tuple functions, as we have seen in the list. It does have len, it does have count, so you can count the index of occurrence of a particular alphabet in this tuple, or so you can have check the index of that particular tuple. It's just like a string operator, most of them. So but the only difference between string is that it can store any kinds of data types inside. That string stores only the character sets. So the final data structure, and the very important and most commonly, or you can say it has an intelligent way of applying in the Python, is the set operation. So set operation is quite similar to the mathematical set operations. So it's nothing but the group of elements, or you can say it's a set of elements. Set data structure. Group has a different meaning though in mathematics term, that it follows some other functionality or some other set of rules other than sets. You don't have to worry about that. So similar to the tuple, we can define a set with the set argument, set function. So when you define something like that, this becomes a set. Or you can also initialize a set operation with like this, or with the flower braces. So the important thing to notice is the flower braces in Python already has one more meaning. It's called as hashes or dictionaries. So if you define an empty hash, empty flower bracket, the type would be dictionary, not the set. So if you have to define elements to consider this as a set. So you can see now the type of both of set 0 or so both of them would be set here. So the main important thing about the set is that, so let's take an example. So it doesn't have a repeated element. So if you have one list, it has 1, 2, 3 and 5, 5 and 6, 6. So this is actually valid a list which has a repetition of 5, 5 and 6, 6. But the important thing, when you convert into an x, so let's say this is a set x. So when you convert it into a set and you try to display you see the magic 1, 2, 3, 4, 5, 6. So it removes all the repeated set of elements. That's the beauty about the set. So if you see here set 1, 2, 3, so let's say we have, and also there are a lot of built-in operations on set that we will see, just like in a mathematical union operation, it has intersection operation, difference and symmetric, or subset, or pop, remove, all those things you can do. So let's see, take an example. There are two sets, set 1 and set 2. So it has 1, 2, 3 and 2, 3, 4, 5. So when you do a union operation, what it does is, so this is the way of writing a union operation, set 1 dot union, and you say you have to union with the set 2. So when you do this, so let's run this as well, sorry. Okay. So when you do this, it's basically going to concatenate and remove the whatever the repeated, this for example 2 and 3 is going to remove, and form a set with 1, 2, 3 and 4, 5. And you can do other operations such as you can add it to the set. So we'll add an element 0 to the set 1. So it's going to add 0, 1, 2, 3 becomes a set 1. And you can do the intersection. So basically whatever common elements in these two will be printed out when you do an intersection. That's 2, 3. So this basically might seem like a mathematical way of doing, but in a programmatic point of view, this adds a lot of value, removes a lot of unnecessary code to be written, and Python handles in a data structure level that will be pretty fast compared to writing a wrapper which does all the set operations. So you can also see some of other examples, just like set difference. Basically we say set 1 minus set 2. This will have the elements which are there in set 1 not in set 2. They are 0 and 1, since we have added 0 and 1 are the set difference values. And set 2, so it's similarly, and you can do a set 2 difference, set 1. So set 2 symmetric difference is nothing but it's all the differences which are there on. So basically it's a minus b union b minus a. So we'll get 0 and 1 from here, 4 and 5 from here. So those are all union, and you'll get 0, 1, 4, 5. So a lot of other operation, like you can check whether it's a one is a subset of that, is it a disjoint, you can remove elements from that, a lot of other stuffs. You can check out the set operation in detail if you'd like to in this with other examples as well as. So this is the end of data structure. So I hope you grasp the minimalistic data structure knowledge we will be needing for the next tutorials.